The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
Ben, are you excited? It's time for Mini Pinball!
Yes, Mini Pinball is going to be our third and final long-term project this year.
So where are you gonna start?
Well, we're going to take a look at the original mini pinball machine that we made that everyone told us would be a great idea for a kit, and then figure out physically how to rebuild it. So I bought a whole bunch of different sizes of steel ball bearings, from 1/2 inch to 1 inch, and then also some metrics in there as well, like 14, 15, 16. We're going to roll those around and see what would feel better for weight, because I think we need to scale the weight.
That sounds like a good place to start.
Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Look, it finally came back to us, the mini pinball machine.
Yeah, this is a fancy, awesome thing.
Yeah, a lot of people wanted us to make a kit out of this. But this was fairly complicated to put together, if you recall.
Indeed, it was.
Didn't we use optos for a lot of it?
Yep, and this complicated mechanism right there.
Yes, where you were like, oh, Ben, let's put this in. I'm like, okay, you have to figure out how to reset it though. So Felix came up with all this, and then I designed the 3D part. That's kind of fun torturing you with that, I have to admit.
No, it was great because I made the H-bridge there.
Let's identify the major parts in this. So we have a battery. Then this is what, the Teensy 3.1 that drives it? Now you said there's a new Teensy that has an SD card built into it?
Yeah,
Or
3.7 I think, or maybe
Okay.
3.6, one or the other.
Like we wouldn't have to add this audio SD card on top of it. And this one has an improved audio chip, but I believe we can get, like there's like a 12-bit DAC built into the Teensy, which will probably be sufficient for this project. We could get rid of the volume knob, we could get rid of the start button, we could get rid of a lot of things. Just have like the 2 buttons. So like when the game is over, like one could select the number of players and the other one would start the game. I grabbed some more switches. These even light up, which I think is overkill, but we can use them for the prototype.
Sure, that'd be fun.
So it looks like we have 8 sizes of balls.
Okay.
I'm gonna see if I can whack around this 1/2 inch ball, or 5/8. Space shuttle. Oh yeah, easily. The original ball that we used for this was just too light and floaty. That's why it had so many air balls. It's also why the game is difficult. So we did a kind of a hack. These brass rails, when the ball goes between them, it completes a circuit, and that's how you know that you scored it. However, the brass is probably slightly oxidized since we built this. Hey, what if we gave people a board and it had like punch holes in it? Different punch holes, and if you wanted to put a sensor or a light there, you pop the hole out, and if you don't, you just leave it. So it could be a little bit more...
Customizable, flexible.
I'm thinking this is the 18 millimeter. It is, all right. That might be a little too big.
This is what you were playing with before?
I like the 5/8, yeah. I guess, you know, it would also come down to what is the cheapest, most common size. So if 16 millimeter is actually more common than 5/8, then we would get 16 millimeter. Can you make me a 16 millimeter label right there?
Yep.
Wow, these little flippers can even move around this 3/4 inch ball. Look at that. But see, the movement's a lot more manageable, even though the flippers look stupidly small. Thing is though, if we scale up the flippers to fit the ball, then there's gonna be more leverage on them, which means there's gonna be more power applied. But if we're using a smaller coil, maybe that will account for that. Are these all the smaller ones?
Yeah, I haven't seen anyone larger than these.
Hey, let's just take them out of the boxes so we know,
Okay.
we know what they are. These boxes aren't all the same. The numbers are different.
Oh, here's a big one.
Yeah, we have at least one big one. Hey, and they come with actuators. That's cool.
Oh, you know what? I saw on Newark they have some sort of custom spring kits for these. Well, there's a spring that goes inside and it pushes it out. That's what it is.
Looks like you got some surface mount MOSFETs here. MOSFET N channel, 80 volts, 39 amps. That should be plenty for this project. Hey, you got your meter? Let's measure these guys. Do you think we should still run this thing at 12 volts?
I think we had the batteries like 14 something.
Oh, hey, maybe we couldn't include the battery. We're like, hey, go to the hobby store and buy your own battery. Also, you don't have to ship.
yeah,
Then you don't have
that's
to
a
ship
big deal.
lithium-ion batteries either. Okay, 11.6. It's the battery pack on this one. It's like a 6 cell, right? That's like 16.5 volts fully charged, Felix. Well, in a shock to no one, this larger coil is also stronger. 7.7 ohms versus 11.7. Are there battery packs slightly smaller than that? Because you're talking 16.5 volts divided by 11 ohms, 1.5 amps. The other one, 16.5 divided by what, 7.7? That's 2 amps. Wow. So we were pulsing this thing at 2 amps before. I mean, as long as it's within spec of the MOSFET, I guess we're okay. Oh, do you think we could rig up a breadboard test with this?
Sure.
And like pass some current through these and just make sure it works?
Yeah. So here's the circuit diagram of what I've wired up. We have 12 volts coming in here. Let me write that 12 volts. Whereas the VDD is 12 volts. Comes in here. I have a diode there. Here's the solenoid. It goes into the drain of the MOSFET. I have a switch right here, and that's going to 5 volts. 5 volts comes into the gate, and there is a 10K pull-down resistor on the gate as well. That goes to ground. And then the source of the gate goes to ground.
All right, Felix is mocking up a MOSFET test. I am going to work on some physical stuff. I have all the different sizes of balls in the entire world. Asterisk between 1/2 inch and 1 inch. Again, I'm really liking the 5/8, but I might also like the 16 millimeter, even though it's very close. Now before, when we did this project, I was really hung up on making it to scale, like a pinball machine. I think that was a mistake because the physics didn't scale correctly. All right, I rigged this up. It's supposed to be 10 degrees. It's 10.7, I guess that's close. Now, pinball machines are usually 6.5, and I'm pretty sure that's what I did with that one over there. I guess I can check. But by having it be too shallow, the ball, was too wild. So by increasing the angle, we can slow it down a little bit. So we can scale the motion in more ways than just size, because size does matter, according to Godzilla, starring Matthew Broderick. As a wormatologist, yeah, this one's a lot shallower than that. So yeah, I think I'm gonna scale the ball up and scale up the angle and then use a weaker solenoid. Okay. Because you know how the ball was like flying everywhere on this one? We just need to slow it down.
Ben wanted some help creating the models for the flippers to test for the mini pinball game. And since I am working on learning how to use Fusion 360 because I want to get into 3D modeling, he asked me to help. So I started by creating a couple different circles in my sketch. And then I struggled quite a bit because I'm not used to thinking how Fusion 360 thinks. So I was able to create one circle, and then I was able to create a second circle over here. And then there's a way to set the dimensions between the two objects. So we want the flipper to be approximately 1.75 inches. The way I'm designing this and the way Fusion 360 allows me to calculate the distance between sketches, at least as far as I know so far, I have to subtract the radius of each circle so that, because it's not letting me measure from the outside of each circle, I have to do it from the center point of each circle. So I'm having to do some weird math. So since we want both ends of the flipper to be curved, I'm just creating 2 circles and then connecting them with lines, and then I can just modify it from there if we need to tweak the size or shape at all later. I'll grab a line there, and a line there, and another one there, and another one there. Hey, look, isn't it pretty? I have so many habits of using Illustrator and the hotkeys. I keep hitting V to get back to my pointer tool. I don't think it's working. Ben showed me the trim feature, which is really useful. So now I can cut off the inner part of this circle and the inner part of this circle, and now it's a complete sketch. Hooray! Then I hit stop sketch. I think it's all pretty. Boy, I forgot something. Before you do that, I forgot he needs a pivot point, which means I need to add another circle to this. Okay, I need a hole. That's an 1/8 inch in the middle. All right, now I can go and do that. T for trim. Trim those off. Stop sketch. Hooray! Hey, look, a flipper. Isn't that nice? Now I can go and extrude this if I want, or do the press pull feature. Rotate this. Boop. So I can see. Let's see, make this like 5 inches. Oh no, I've done it wrong. Or I just turned off bodies and I'm being ridiculous. And there we have a nice little flipper. Look at that. Isn't that fancy? So we will try 3D printing this, and Ben will put it on his little game and we'll see if it works. Probably need to modify it slightly. but it's a start.
Okay, so I've taken Karen's basic flipper design and I've turned it into another body. And what I've done with it is I've added some things at the bottom. So here's what it has. It has a little bit of a lip here. Oh, and I have the real piece too. It has a little bit of a lip which will keep it off the surface of the Playfield. And then there's a 6mm barrel in the middle. That'll be the thickness of the material. And then below that we have a 3D printed hexagonal shaft. Now what I'll probably do for the real thing is have this be just a piece of steel, but I don't have that ordered yet. So I just 3D printed it for now. The thing that would be nice about a piece of hex steel is you can only mount it the correct way, and then everything will rotate together. Okay, now on top of that, we have the first part of the linkage. So this is kind of like the upside down from underneath view. And so this is the part the solenoid will pull on. So I've got the second part printing right now. Then I just need to make a little bit of a linkage and then a mount to hold the solenoid. And then we'll have a proper flipper assembly that we can do more tests with. But yeah, so I'm kind of designing it from the flipper bat out. So the flipper bat is, normally it's rotated down 35 degrees and its amount of flip is 50 degrees up. What I did was I took the throw of the solenoid and I realized that it's half an inch. So then I figured out, okay, I need to rotate 50 degrees using half an inch of linear motion. And that's where I have these points here. And this represents the throw of the solenoid. So that should get the flipper the right amount of motion it needs off of the short half-inch throw that the solenoid has. And Felix is over there wiring up left and right MOSFET controls. So hopefully we could try both flippers and then start putting some things on the Mockup Playfield to get an idea for what size is best. So it's like the strength of the flippers, the size of the solenoid, the length of the flippers, the size of the ball, the tilt of the playfield, and then how deep it is. And we're gonna mix all those together and try to make a playfield that's not too big, but also one that is more playable and has more control and weight, as opposed to the original version where the ball is just flying all over the place. Okay, Karen, I redesigned the flipper based off some of your thoughts.
Yeah, it looks good.
So you didn't want the hexagonal rod to rotate in a cylinder, right?
I thought it was a bad idea to have something that's hexagonal rotating in a round slot.
So what if we did this with the flipper? So we have the shaft coming off the flipper, which the hex fits into, and then we'll make a mount around that.
Yeah.
And that mount will fit into a hole in the 6mm wood. And so the round portion will rotate in there. And we will have to adjust the linkage. Like if you look at here, like when we turn the linkage on, oh wait, not the linkage, the actuator. See how it intersects? So we'll have to modify that, but that's not a big deal. But yeah, I think that seems pretty good.
Okay.
I'm a little concerned as far as the 3D print goes, like this may print too hot and not keep its shape. But I mean, it might be okay. I'll print up these pieces and then we can try to give them the mock-up and see if we get better motion.
Cool.
All right, I've increased or decreased the angle of the flipper. See, my concern is, well, I'm gonna rig this up again with two flippers, obviously. I think this mech is working pretty well. Thing is, like, even if you had two flippers, you'd be shooting to the left and the right, and you would very rarely shoot up the middle. So, like, if I wanted to go for the middle normally, I'd be like, see, and look, I can't do it because we're relying more on the fulcrum of this, basically lever than we are its force. So the thing is, it would kind of make it hard to hit things. I mean, another thing you could do, you could spread the flippers out a little artificially, but then you're gonna have a big gaping hole in the middle, unless we had some sort of post there or rubber. So the flippers would be further out, so you'd be still going in this direction, but if the flipper is more to the left or the right, then you have more things to hit. So it's a larger flipper, a larger ball, and a smaller solenoid. The angle is also 4 degrees steeper than the original game. But this flipper is like, oh gosh, almost twice the size as the one in this one. Oh yeah, this flipper is almost twice as long. So the ball always is having a left or right velocity. So when you hit it here, it's always gonna go in that direction. I wonder if you did it more like, see, you can actually get more vertical motion like that. It's kind of like a sling. Like if you throw a rock, like, oh, I'm gonna throw a rock at something, and you have this much of a fulcrum, you know? Now, if you have a sling, like if it's like the Roman times or like David and Goliath, so you've got this rock at the end of something else, so now you've got a much bigger fulcrum, so the rock's gonna go even faster. And that's kind of what's happening here. It's, the ball is the rock, and this is our sling. Now, if the flipper's bigger, we could get it to go even further, but we're gonna run out of space. And also, the longer we make the flipper, the more force it'll take to move something at the end of the flipper, which I don't think our solenoid really has.
We made some really good progress on the pinball game.
Yeah, we took a look at the existing old game that we made, and then we did some changes. We tested a whole bunch of different sizes of balls. We settled on 5/8 as what we think is probably a good size. Then you designed a new flipper, which is longer, which gives us more action from a smaller solenoid. Then Felix wired up a board with some smaller surface mount MOSFETs, metal oxide semiconductor field effect transistors, and those are used to control the smaller solenoid. So basically, we're trying to keep the pinball about the same size, but use smaller, cheaper parts. So what we'll do in a future episode is design more of the game around it, do some analysis of the ball's motion, and then figure out the best ways to make this a kit that people can build at home.
If you have any comments or questions about the build, or ideas for improvements we can make, let us know on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. Great Pharaoh, I'm sorry. I left our holy glue sticks out in the sun, and Ra melted them. You are condemned to the mines of Syria. No! The guy gets drunk. It's a good thing we invented beer. Oh crap, I left the holy glue guns out in the sun. And apparently they can melt.
So there's some dead project and other projects come
Eat
up
it?
to it. And, yeah.
Pretty
like
much,
that,
yeah.
Like that robot animal game.
You mean like Horizon Zero Dawn?
Yeah.
It's so cute! It's like a puppy! The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.